Today we will begin talking about trig identities, one of my favorite topics in pre-calculus, so get excited. So trig identities are really just substitutions used to simplify problems and to prove basic statements. So you should have a purple sheet handed to you. If you don't, please make sure you get that. And what we're going to talk about, the first identities are the reciprocal identities, and you should be familiar with these. It's just knowing, for instance, that sine of theta is the reciprocal of cosecant, which means sine of theta equals 1 over cosecant of theta, and cosecant of theta is equal to 1 over sine of theta. Cosine of theta is 1 over secant of theta, secant of theta is 1 over cosine of theta, and then that tangent and cotangent are reciprocals, so tangent of theta is 1 over cotangent, and cotangent of theta is 1 over tangent of theta. So if you need a second, pause the video, but make sure you copy these down on your purple sheet. It is really important that you have these filled in because we will be using them a lot in the future. The next set of identities that we're going to talk about are quotient identities, another thing you should be familiar with. And that's just knowing that tangent of theta is equal to sine of theta over cosine of theta. And cotangent of theta is equal to cosine of theta over sine of a theta there. All right, and also Pythagorean identities. So knowing your Pythagorean identities. Sine squared of theta plus cosine squared of theta equals 1. I would star this, highlight it, whatever you need to do, because we will use this identity in particular a lot. The other two are that tangent squared of theta plus 1 equals secant squared of theta, and cotangent squared of theta plus 1 equals cosecant squared of theta. These are all also able to be manipulated. For instance, say I wanted to know what sine squared of theta was equal to. Well, I know sine squared of theta plus cosine squared of theta equals 1. If I subtract cosine squared over, I can state that sine squared of theta equals 1 minus cosine squared of theta. And so I can use that as an identity as well. All right, so make sure you have these identities copied down, and you will want to start working on memorizing them because you will need to know them. And however, they should be pretty familiar with you already. So what we're actually going to do is we're going to simplify the following. So we are going to substitute in and use these, and what we'll do then is simplify as far as we possibly can. So cosecant of theta we just talked about is a reciprocal to sine. So cosecant of theta is 1 over sine of theta. Tangent of theta would be 1 over cotangent, but that's not really going to help us here. What would help us is if we use the quotient identity there. And that would mean that tangent of theta is sine of theta over cosine of theta. And we do this because what happens now when we multiply is our sine of thetas cancel each other out. So we're really just left with 1 over cosine of theta. And 1 over cosine of theta really just reduces to secant of theta. So you wouldn't necessarily know looking at right away cosecant of theta times tangent of theta equals secant of theta, but it actually does. All right, tangent of theta times cotangent of theta minus cosine squared of theta. All right, well, tangent of theta times cotangent. There's a variety of ways I could recognize that cotangent is the reciprocal of tangent. I could write it as 1 over tangent. So your tangents cancel out, and you're just left with 1 minus cosine squared of theta, which, if we go back up to our Pythagorean identities, 1 minus cosine squared of theta is just sine squared of theta. So your answer here is just sine squared of theta. Another way you could have looked at this is tangent is sine of theta over cosine of theta times cotangent, which is cosine theta over sine of theta, minus cosine squared of theta. And these would all cancel out to just 1. Same situation, same solution, just a slightly altered way to go about it. And both are perfectly good options. All right. Number 3 is 1 minus sine squared of theta. So remembering the identity, cosine squared of theta plus sine squared of theta equals 1. If I subtract cosine squared is 1 minus. This is cosine squared of theta times secant of theta. So this is cosine squared of theta times secant is the reciprocal of cosine. So that's 1 over cosine of theta. And what happens is you can cancel one of your cosines out. And this reduces nicely to just cosine of theta. So as you're seeing here, we're not really going to be dealing with numbers or anything like that for a little bit here. We are just simplifying and substituting to cancel and reduce as much as possible. So you need to show me every step here. That's really important in order to make sure you get full credit, is showing your entire thought process. So yes, you can cancel and you can do all that multiple parts at once, but you need to show your thought process as you go. All right, secant squared times tangent squared plus secant squared of theta. So when I look at this, you want to look when you're doing these problems for ways to reduce or factor. Factoring is a great way to go about this. So when I look here, I see that they both have a secant. Let's go ahead and factor it out. You're then left with tangent squared of theta plus 1. Whenever you see trigs or trig functions that are squared, rather, you kind of want to have a hint there to look for your Pythagorean identities. So I see right here that tangent squared of theta plus 1 is secant squared of theta. So this is actually secant squared of theta times secant squared of theta, which is no different than x squared times x squared gives you secant to the 4th of theta. All right, so I'm going to stop this video here, and we're going to move on to cofunctions of complementary angles in the next video.